So this is Leetcode problem 695, max area of an island. And the problem is given a 2D array, which is comprised of 0 and 1s. An island is a group of 1s connected horizontally or vertically. And you may assume all 4 edges on the grid are surrounded by water. Find the maximum area of an island in the given 2D array. If there is no island, return 0. So in this example, the answer is 6 because you're not looking diagonally. You're looking only up and down. So here it's 1. These ones are connected 2, 3, 4, 5, and 6. And in this example, given the above grid, you return 0 because there's no 1s in it. So there's not even an island the size of 1. So for this problem, the way I thought I would approach it is you're going to go through the array. First, you're going to have to go through each line, and then within each line, you're going to have to go through here. So it's going to be 2 for loops. And when you find a 1, you can run a DFS on it, and the DFS can search up, down, left, and right, and continue on and count that as one island if there's a 1 connecting. So again, the first thing I was going to do is 2 for loops with a 2D array. So if you find a 1, you could send it to DFS. If it is the base case, which we'll define later, you return 0. If it is a 1, we're going to change that 1 to a -1, so that way we won't count it again. We won't count it as a 0 or a 1. And then we will add 1 to our current island count, and add the top left, going top left, right, and down. And yeah, that should be it. But also in this 2D array here, we're going to always keep track of the answer. We're going to return the maximum amount. So let's do this. Needs an int returned because it's asking for an int. So int answer is going to be equal to 0 to start off, and at the end we are going to just return answer. Let's do our 2 for loops. We'll start at I equals 0, I less than grid length. And because we can do grid 0 because we know that every line is going to have the same amount in it. Grid length J++. And we're going to say, okay, if the grid I j equals 1, we're going to say our answer is going to be this, which is 0, or the DFS of I, j. And I'm also going to pass the grid so that we don't have to keep that as a global variable. So that's the first part, and then so now we have to define our DFS. So our DFS is going to return an int also. Which is going to have an int I, int j, and grid. So our base cases are going to be, okay, so if I is less than 0, or I is greater than or equal to the grid length, or j is less than 0, or j is less than, or greater than or equal to the grid length, or grid I j equals 0, or grid I j we've already looked at and it was already a 1, it's going to be equal to -1. So if it's any of these instances, if I is off the grid, either to the left or the right, or j is off of the grid, then, or if the grid is, we're at a 0 or we're at a -1, what we're going to do at this point is we're just going to return 0. And if it's not any of these, that means grid I j is 1, and so we're going to turn it into a -1 because we don't want to count it again. And from there, we can just return 1 plus DFS. We're going to go I plus 1 plus I minus 1 plus, leave I alone this time, we're going to go j plus 1 and we're going to go j minus 1. Okay, so let me make sure that is right. Okay, so we're looking through the row and then the column, and we're going to say, okay, at this row and column, if it's a 1, we're going to run DFS on it, and this will return the answer here. And we're going to keep track of it with answer. We're going to just say, like, okay, only update our final answer if it's the maximum amount we've seen so far. And here in our DFS, if we are going out of bounds, or if it's a 0 and not another 1, or if we've looked at it before and it's a -1, we're going to return 0. We're going to change our 1 to a -1, and then we're going to return 1 plus whatever else these are. So let me try to. So that is correct for 0, 1. Let's do this test case here. And I think I have to update these here so that it doesn't like this line here. So that is 6, and that's correct also. But let's look each time and see what the answer is as we're keeping track of it. So every time we're going through this, the current answer is going to be 0. The current answer is 1. So the current answer is 0 when we first find a 1. So it's probably right here. Then it's going to, right here, it's returning a 1. Then eventually it gets to 4, probably right here, 1, 2, 3, 4. And it stays at 4 even when it sees these. It stays at 4. Even when it sees this one, it stays at 4 until finally it gets to this one and it turns to 6. And then there's no other ones that are counted. So that's it. And let me just put this here. Okay, thank you.